Yes, why not? All right, cool. Here is this. Let's get rid of this. All right, so today in VIS, that's the syllabus assignments. This is week 3. And that's that. Oh my God, hold on. You could also, in the Miro board, any of your Miro boards, you could also just make a comment and I'll get notified about it, especially if you make a comment, for example. It's a pretty cool feature. You could make a comment and then like, you could tag me in it. So you could actually like call me out on it. And then I could look at whatever you need me to, if you don't want to, just as an example. All right, so today's VIS assignment. That's my iTunes. I don't need that open.
Because with the lady, she broke her shoulder in the building. Isn't that funny? You know that one of the friends, one of the dad's parents, he's like, yeah, she broke her shoulder. Our parents, I let his Puritan do this.
So I was able to use an example from a student from my design class. So I'm just going to walk you through some of the examples and the assignment for the project. It should be pretty straightforward. So for week 3, we're going to be analyzing the spatial vessels. So you kind of got an introduction about this in your design class, but the goal is to investigate methods of scaling, orienting, intersecting, and sequencing multiple vessels into one scene through the use of Boolean operations, then analyzing the scene, spatial relationships, opportunities through plan, and section drawings. So the key words or the key concepts here are additive and subtractive. So additive being a strategy of making characterized by accumulation. Oh, I just read that weird. A strategy of making characterized by accumulation. So you're adding pieces. A lot of last semester was all additive, adding sticks and walls, right? So that's Boolean unioning, which we learned last semester. And then there's a subtractive method, which is basically the emphasis on this semester, where we're going to be, instead of adding, we're subtracting. So remove matter from a solid, the process of making that is characterized by removal. So for the assignment this week, we'll continue to develop the volumetric vessels, working with, keyword here is 3 at a time, developing a method to combine the volumes through intersecting, considering orientation, geometry relationships, and we're going to test and analyze multiple iterations. So the best thing is about this part of the assignment is that it's quick and easy. So you should be able to come up with and analyze your 3-dimensional objects and combinations of 3-dimensional, these vessels. You're going to come up with these combinations quickly. So you can analyze them and look at them in their composition, both in 2D and 3D. And you can figure out which one works best for your design. Because it's kind of a never-ending amount of opportunity and options to manipulate these profiles and put them together to create something new. So the idea is that you're creating your own rules, regulations, combinations, like you're setting up the parameters to make it your own design. And you're going to have 3 of those designs. Those designs, those iterations are going to be referred to as scenes for the semester. So you scene 1 is your first combination of profile vessels. Your scene 2, different combination. You should use different rotations, different combinations. So whether you're manipulating those profiles in similar ways inside one scene or a multitude of different manipulations, it's kind of it's kind of open-ended. I mean, you got to just make the decisions, commit to it, and then keep modifying and adjusting as necessary. I would look at Corbu's painting and stuff, his designs, his profiles. You can get inspiration from literally your painting, his painting. Just kind of look at how he orders things. So if you look at an example of one of his, right? I'm recording just my face again. Remember that? I did that whole class of just recording my face. This has been 15 minutes of just my face.
A good thing you're reading the instructions.
Yeah, right.
Not sure what to do.
Yep. So, for example, when you're analyzing his paintings, it's kind of interesting. Like you could pick up some certain regulating lines, right? So this is almost like kind of quad. So you have, if this is A, right? You got a sliver of A, you have B, you have C, the negative space in between the bottle and the stronger objects. Maybe this is like a B, it's almost a very similar width. And then you almost have an A over here, right? So you have positive and negative space, and he organized these spaces using some geometries, and a lot of those geometries have straight lines or joining surfaces or similar curves and connections. So you can use those to populate and create your own combinations using those manipulations that we came with. So when you look at it in profile, is this too literal of this object stemming out of the ground here, right? But at least you're committing to something and kind of looking at it, right? So when you look at another design, is this one here, we talked about it in class earlier, like, is this too empty, right? This is ordered in a way where it feels like there's no order, right? So maybe you can start manipulating with the scale of some of the pieces to create certain geometries, rotating and filling different shapes so that you can create a datum similar to the horizontal lines in the painting. But then, how do you create hierarchy between the shapes as well? Like, you don't want so much white space. And you should be working through your 3D model. Look at the plan, look at the front, look at the side, right? Look at all of the interactions 3-dimensionally and not just statically. So the idea is that if we had them pulled apart, right? This one was literally going off the concept of what if it was the shape of a bowl, right? So you could start there and then look at it 3-dimensionally. And just because the side looks like a bowl doesn't mean every side looks like a bowl, but at least you can start somewhere to put these pieces together. So now we're going to take the pieces, the vessels, and we're going to push them together, which we talked about in design today. So for example, when we push them together, they now have physical connections. How much are they touching? How much are they intersecting? Does one penetrate all the way through an object? What is the hierarchy? Where are they located? What is the relationship to not just the vessels surrounding it, but the vessels it's touching, and its location within the whole of, you're creating a sculpture, right? You're basically creating a 3-dimensional painting from a painting, right? So think about that, and you could use the frames as proportional things to kind of analyze, am I centered? Am I off center? Are you creating space in between objects, right? If something is so close that it's not touching, should it just touch and combine, or should it be separated further apart? There's this weird thing that happens when things don't touch or touch. It needs to make a decision. You don't just want it to be like a millimeter away. It needs to either combine or it needs to be pulled further apart so it has more tension. It can't just be so close. It's so weird. So you want to look at the plan, right? Moving back and forth between the 3D views and the 2D views. So we're going to be showing, I'm going to be showing you in VIS, like how to make, it really was Alex.
It is. It's good class.
It's right there. So you want to combine these things together. So we can analyze, their positive and negative space using our two-dimensional conventions, right? The plans, sections, and annotations. I have no idea what's happening. So the processes of develop, edit, set up the Rhino file to produce 3 combined volume iterations, quote unquote, the 3 scenes, right? This doesn't exist anymore. Use Boolean operations to join the discrete volumes into one. The biggest thing to note about this assignment is this is where it starts getting complicated. Like if you thought making the forms were complicated, now it gets more complicated, right? Because now we have to combine them. The biggest thing is it needs to be a closed polysurface. Like these things need to be solid pieces. It needs to combine. If they are open, the Boolean operations won't work. So not only will it not cap or whatever, it won't join, it won't combine. Rhino is very sensitive, I guess would be the best word to describe it about it. So you're taking your vessels and you're going to combine them and then Boolean them. So that way, when we use our clipping plane to create plans and sections, right? It won't be like last semester where if you didn't join them, you can kind of tell where things stopped and started. It gets a lot more complicated with these objects where you can't tell the exact lines of where these things are stopping and starting. But if you union them, you'll be able to specifically see that object starting and stopping. So for 1A, or the first part of the assignment is that we're going through solids, right? So by that, I mean here. For example, if I have a cube, right? Not pretending that this is a vessel. Maybe it is, whatever. If I have a cube and then I have another cube, and these are 2 separate objects, right? I guess it's more fun when you see the faces that I make. So let's make this one our purple object. Let's make this my green object. Right. I'm going to make a copy because I need them separate. If I Boolean union them, right? I can't un-Boolean union them. I can't unseparate them. So I want to always have a copy of my project before I Boolean union it. Because if I'm your design professor and I ask you to manipulate a shape differently, like maybe the twist was too hard or the composition would look better if it was a little bit taller, but just that one object was taller, you can't just manipulate that one object anymore because it's solid. It's part of the piece. It's already unioned. But if I have a copy of it, I could then edit the piece however I need to. There was literally 2 of them drawn on top of each other. I could edit this however I need to. And then I can make another copy. And make another copy. Because the biggest thing is that when I'm looking at my clipping plane, and I cut these objects, right? When they're not joined, when they're not unioned, right? They're separate. But when they're unioned, it becomes a singular object. Does that make sense? So when I'm asking you guys to make plans and sections of your three-dimensional pieces, hold on. You will be delivering this. 2 plans, 2 sections, 1 isometric drawing with annotations showing me with the flags of where the sections are cut, showing me the bounding box of where your objects are located. Does anybody have any questions about that? If you don't do this and you try to put it in Illustrator and just fill in the objects, you're going to get all those weird lines. It's going to be a total nightmare of all of these weird, intricate shapes. But if you combine it, and I'm only asking for a black and white version of this, if you union it, it'll give you that clean poche that you can easily fill in. So I used one of this is George's project. Where was the pieces that we were working with? I think it was this one. So when you have your different objects, wait, where's the other one? So for example, we found out today that he couldn't union this because it wasn't capped. So if your object isn't capped, right? See how it's open at the bottom? If it's not capped, it says at the top, union failed. 1 closed poly surface added to the section. Where is it? In progress, and it'll tell you it'll fail because it's not going to work. But if I cap it, and then union it, I now have a combined piece, solid object. But I forgot to make a copy of it, so now this is locked forever. So you'd have to either, I can undo it, but so notice how it took over the properties of the layer or the layer status. And so even if this is purple, it assumes that if you want that single object, you can't have a single object on 2 different layers. It's a single object now, right? So what we found out with George's project is that my Boolean union failed for this piece and this piece, right? But if I take this piece out and I know that it's a solid piece and I know that it's capped and everything is great about it, right? I can do a test with myself And I can see if I just take a simple shape and union it with a complicated shape, right? It lets me do it. And if I take this other shape and I try to union it with a simple shape, it also works. So what Rhino is telling me, based on my analysis of Boolean unioning these simply versus more complicated, is that it doesn't like the output of this object and this object touching each other. So somewhere in between here, something weird is happening inside Rhino, where like either pieces are too close or there's something like inserting itself where it shouldn't be. But Rhino's going to keep telling me no, even though I can union it to anything else. So I can union these two pieces, no problem. I can union these two pieces, hopefully. I can't union those. So for example, if I take this piece, and maybe I move it over here, and maybe I lift it up a little bit because it was perfectly on edge with that one, you know, I can aesthetically look at the design and say, you know, maybe it's better over there. So let's try it again. Now it lets me. Sometimes Rhino is so sensitive that it doesn't want you to put the thing in where you want it to go. So it's going to create some roadblocks, but you should integrate those roadblocks into your design. The roadblocks, if the shape is wrong, it won't union with other simple shapes. But if the shape is closed and you know that it's closed and you try to integrate it with another complicated shape, it might just need to be like nudged some way or another to fit better. So try to keep that into consideration, because almost every single one of you will send me or like raise your hand in class and be like, this isn't unioning. I don't know what to do. It's not working. The idea is you might just have to move it a little bit. It sounds so rudimentary, but like Rhino will do that to you. So now we never actually, we never figured out so now I have this piece is one union, this piece is another. Now I accidentally. So now even without moving this piece, I just unioned this in a separate order, and now it let me put this one in that one, right? So don't know exactly why that is, but it worked, which is great. I would assume it's probably because they were on such a simple plane. And if you want a hard line or a surface like that, you could also always take like a rectangle, a cube, and you can kind of slice the last sliver off of your project to create a hard line or a hard edge, rather than just union them on the exact same surface plane. I find that sometimes if you try to union two objects together, for example, like this one and this one, well, I just bring it up a little bit, or if I bring it down, say I just want it there. Cool. So now it's one object, but I want it to be a hard line underneath. we use our friend Boolean difference, right? The object I'm removing from, the object I'm removing with. And now I have a continuous clean edge at the bottom. But now I also don't have a copy of the project. So I can never go back to nudging that back up and down. So save, seriously, like save your project every week or every Tuesday and Friday, just make a copy. Like call it 1A, call it 1B, call it 1C, like keep copies of your models. Because you also, sometimes you just making a million copies this way, but you lose this file, it gets corrupt and something, blah, 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 I lost my Rhino. Happens all the time. If you make a copy every week and just save literally the file in a file location every week, you won't have to start from scratch. Because this is where it starts snowballing into, we're going to keep using these shapes, we're going to keep manipulating, we're going to keep unioning. Like this whole series gets very complicated. So you want to make sure that you have a backup, not just a duplicate inside the exact same Rhino file. You want to have backups of your Rhino project. Okay, part 2. Hold on. I'm just going to close my email so no one can look at that anymore. Questions so far? Cool. Part 2 is excavation, right? So if I'm unioning this to be a solid, where's my good solid? This one. Seriously, not a fan of that green color. We have the painting in here somewhere. Cool. It's more fun. All right, so if this is the solid, we're going to make the negative. The best way to make the negative, because you will have your like frames and armatures, right? I'm going to build this faster than I did last time. All right, so let's say you have so if you have your frame, in relationship to like your painting, maybe this one. All right, so there's your boundary box. If you place this within your painting or your frame, there's two ways you can make the bounding box for your object. You can just simply make like the cube of see how it's operated or, the exact height and width and try to figure that out as fast as you can by using like the scale command, etc. Or there's a really easy way to do it. Click your object, type in bounding box. Press enter. I now have a box the exact area of that object. So the way that the Boolean differencing works best is that you scale that up, like scale that box just like a little bit shorter and a little bit skinnier so that you want the box to be either on the inside or the outside. You don't want it to be perfectly on the edge. When it's perfectly on the edge, it's going to give you some issues, potentially. It doesn't happen every time, but it does happen. So I'll show you one example. So you have one that's directly on the edge. One that's a little bit skinnier. And then maybe one that's a little bit taller. There's two things that's going to happen. So this one's fully enclosed on all edges. This one's directly at the edge using the bounding box, and then this one is slightly inside. Should it be inside more? No, it's fine. Maybe it wants to be a little skinnier. Cool. So you're going to use the Boolean difference command, select surfaces to subtract from. We're subtracting from the cube. Right. Just in case. I'm going to make a copy. So we're going to subtract Boolean difference. Subtract the surface that we're subtracting from the cube, press enter. Subtracting with the object, press enter. It's going to think, your computer's going to do some complicated stuff. We're going to do this command again. Subtracting from the cube, enter. Subtracting with the object, enter. Subtracting Boolean difference in progress, Boolean difference failed, cool. Subtracting from the cube. And subtracting with the object's inside, so I can't see it. Go into wireframe. Objects do not intersect, nothing was done. So when it's completely engulfed inside, sometimes it doesn't want to remove itself. They're not like intersecting, it's literally totally enclosed. So you can actually pick an edge of your object. Maybe it's that back part right there. Why is that there? And I'm just going to have that part stick out. Oh, wait. All right. Cool. And once again, I just nudged this one in the middle. I just nudged the box a little bit to the left and it let me do it. Like just moving it a few inches, let me Boolean difference it. So now when you look at the shaded version and we turn on our friend clipping plane, and we make this not blue because that's not helpful. We now have the inverse of the piece. So you can select the one you like the most. Well, so now it has different qualities and different properties. And now you can cut your plans in sections, and then this, because it's solid, right? This will be a solid surface that you'll be able to fill in. So when you go to your top view, you have a lower plan. Of your solid and a lower plan of your void. So if you do these processes together, you can cut the sections and the plans in the same location if you line it up correctly. You can add reference points to make sure that your sections and your plans are cut in similar points. Cool. So those are my plans. And now if I go I guess that was an upper plan. I cut it pretty high. Go a little bit lower. That's interesting. Make 2D, top view, blah, 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 blah. I don't know why that didn't work. Hold on. Oh, duh. I had it off. Is that why? Why is this not? Hold on. I hate this file. What is actually happening? Oh, I'm an idiot. I mean, that's not a nice word. I am not paying attention. Anybody know why this wasn't working? Because the clipping plane isn't turned on in my top view. Ta-da. Thanks for paying attention, guys.
Always.
What am I not doing? Cool. So it looks identical, but one will have the solid, one will be the void. So you can export that and set up the annotations. Is anybody confused as to how I would go about making these drawings? So I'm going to walk through that. Okay. So here's one of the plans. Probably not even hot anymore. Oh, if you don't see this when you're opening up Illustrator, your Illustrator is not up to date and you should update it. So you can make the lines black. Whoa. So what Illustrator or what Rhino will start doing is it'll start showing all of the surface lines in your objects, right? And it's not the best thing to look at visually. So if you look at some of the examples, you have all of these lines, right? And all those lines are the curves. So you could take those. Are they separated out as a layer? Hold on. If we're lucky, they're its own layer. If we're not lucky, then it's not. So this is the cutting line, right? Those are my layers that imported from Rhino. So I could hide all the curves. I could select these and I can go into properties and make those strokes bolder so that I know that that's what I'm cutting. That helps immensely, right? And then if I go back and I flip that, I can now select all of this. Properties, stroke. You can kind of pull down the colors a little bit so it's not as strong. Turn that back on. Right? This looks odd because the curves are drawn on top of the cutting plane. So you can flip that. Right? I made this way too light because you can't tell what it looks like because it's selected, which is wonderful. Grayscale. Something like that should look good. Turn the clipping pane back in. And we want to poche it so we can turn those curves off. Select everything, object, live paint, make. I think it was a letter K, right? Black. So instead of black, maybe just pick $60. So this is our box. This is our solid object. Turn that back on. So when you see the box full, right, you're not going to see anything that's happening underneath the cut. It's doing it for you, right? And then this is the outside of the shape. You could, if you wanted to, right? You could go in and kind of update just the lines on the outside. So it makes it look more of like an axon drawing where like the outside lines are the darkest. So if you wanted to start doing that, it's going to take some time, but it might produce a better drawing overall. Make it pop a little bit more because these curves aren't really there. They're just there because the object is curved, but like visually it's not really curved. It's just like a shade. And if you want to go the extra mile, you could actually render that and put the rendering underneath the object. So if we look at top view that's being clipped. I would suggest making surfaces in your model. Oh boy. So you can make surfaces in your model to act as the reference planes, so you know where you're cutting your object, right? So now I know that this, oh my God, this red object is where I'm cutting. That is the plan. So when I make another plan, if it's higher or lower, I won't forget where I cut the first one. Does that make sense? Does anybody have any questions so far? I feel like I've just been talking into the void of space. No one has a question. Okay, cool. So this will be my second plan. And I would just make 2D of that area. So then I can go here. This is like the most systematic you'll ever have to be in this class. And you can figure out where you want to cut your sections. If you're doing 2 sections, I would suggest doing one horizontally and one perpendicularly. So make sure that they're perpendicular to each other. Right. And what area showcases the most interesting part of your project? Is cutting a section through here the more interesting? And then cutting one through maybe here, or you want to highlight the void in the project so you can cut it a little bit further down, like in the middle? Or is it more interesting to highlight the fact that this is actually connected? It's a weird part of the project. So maybe it's like here looking in that way. And then I can take this and I can stretch this horizontally. So it shows up on both of them. I can take this one and turn on the wireframe. So now I'm making sure that I'm copying the horizontal section cut in the identical location, because that's my solid object versus the void object. Turn that back off. Is this making sense? What? Maybe I'll stop recording and just do this all over again. So now I'm going to do the section cut. Right. So I'm going to look at the, which one is it? On the right side, it looks like. So I go to that section. What did I just press? Display mode set to pen. I definitely don't want that. Oh my God. Cool. Here are my sections, and because the clipping plane section cut lines are on a different layer, that's great. So when I export, section. So you could preserve the model scale. So like 1 inch equals 1 inch. I don't know if I'm using a model that is to scale, so I'm not going to deal with that right now, but ideally yours is to scale. It has that 10-inch height. So you want to maintain those dimensions. So when I go in the sections, it's the same process, right? You guys remember? These are just the reference lines. So I can kind of go in here. And when I see that red box, I know that that is one of the layers for those lines. Without that red box, I wouldn't know exactly what layer I'm actually clicking on. So I can create a new layer so that I know that I want that to be different and organized. So I'm now going to take this. This. You could press and hold Control. You could select multiple things. Right, I can now drag, pull down, and drop. I could turn that off for now. Select everything over here, properties. Update the stroke. Grayscale. Black. I have the layers open. Minimize. Turn everything on. Select. You'll be able to, yours will already be to scale, so I'm just updating the scale of mine for now. Just a little bit easier to work with. Okay. So now I know that these lines are the lines of the section cut, so I can go in here. All right, properties. Update the stroke dashed line. You could leave it red, you could leave it black, you could leave it gray, whatever you want to do. And then you could identify what way that section will be cut in the plans. Sometimes you can show where the plan's cut. Sometimes you don't have to. I'll leave that up to you just to see how it goes. Just know that it's nice to see where the plan is cut, especially with these complicated objects. So I can turn off those. I can turn this off. I'll select all these lines, properties, make it consistent. So if the other one was, what was this? 3, then this is also 3, right? 3 and 3, it's black. Object, live paint, make, fill it with whatever color we want. You can make it grayscale. Got a 60%. You want to flip these two because they're not on top of each other. So it's like that. Turn this one off, turn all this on. I think we made that. So those are my cut lines. Sometimes people show it with a dash line like you could do on the example, right? But you also want to add a flag and a reference. So you could I removed the plan. I think I deleted the plan one by accident. It's my bad. So show me the flag. Should be like no bigger than that. If you use red, this is actually kind of distracting, so I'll just use black. Oh my God. So some people show like a dash line going through. My personal preference is that's distracting. And I like just kind of seeing just a simple flag like this. Maybe it should be closer to the drawing, but it shouldn't be touching the drawing. And then you can kind of type in S1 or S-1 for the section 1. You could even just use letters like A and B. I think the example uses S-1 for section 1, right? So I'll go over here, S-1. Thank God. There we go. All right, now this is too long. Cool. Sound good? Am I making sense to everybody? So now you can just simply copy that, rotate it, or flip it. Section 1, Plan 1. Sound good? Yeah. Oh, great. No question. Just thumbs up. Go.
I do have one question.
Great.
For the start of the whole thing, the 3 objects that we're selecting, is that from our last assignment? We're picking 3 of those and combining them, or is it from the 1B on the design side? Like, are we taking those objects and meshing them together, or?
You're taking your objects from, this is letter, today was assigned letter E. So
From 1C?
in design. It's from the objects in the design class, which basically come from the objects that were produced for the taxonomy. So that would be C.
Okay.
Correct.
Yeah, so any of those. Chart.
Yeah, so like your manipulations from the chart. Yeah. It's like you pick them from here and then you arrange them and combine them to make the series.
It's only those 6 shapes, right? And the other ones.
What?
It's only those 6 shapes. You put different seeds.
You can have different combinations of them.
We
When
combine
you
it all
do find a section, all of them, or
Hold
all
on.
18 pieces.
This is where it gets a little complicated. Hold on.
18 pieces.
666, so.
What I forgot to do in this version is that when I do an axon of this, I won't be able to see inside, right? So because your bounding box, if your bounding box is bigger than the object, then it's only going to be the inside. You want to pick one where it's a little bit smaller or smaller enough so that when you're looking in perspective, I really just hate this color and I don't understand why. when you're looking in perspective, if you were to cut the axon from this corner, the one where I made the box smaller so that you start seeing the inside of the carving, and maybe you can even look at it this way. And you guys have frames and armatures, so you can look at this one where at least one face is kind of exposed, so you're not just creating an axon of a cube. Yeah.
Don't you use two different things and then create the accent with the two different things?
You could, yeah. Yeah. But I think this one's just showing the outside version here. Another thing you could do, right, to highlight this is if I use this one, right, and I just want the axon of this, I'll bring it all the way out here. And I'll look at it in the I really like the other view better. Great. I don't know how freaking compass works apparently. Hold on. It's the west one I wanted. Cool. When I make 2D, I could either, I'll make two versions. One like this, just to show you an example. Bring that over there. And then one with the hidden lines on. Cool. This will be fun. So right now I'm just going to take literally everything in that one top layer, because I made them the same drawing and that was a great idea. So I'm just pulling these lines away from that object. Oh, I didn't even need to make this separate one. Look at me paying attention. Okay. So those are all the hidden lines from that object. You can leave them on. Right. You're gonna get a lot of weird things like this. You might want to go in there and start cleaning it up. Right. A lot of weird glitchy stuff. You could also go in here. You might want to just make these interior faces, whatever they are, you can make them maybe just a tad lighter. Like if that's one. Let's see what we got here. We got one. We got two. Two looks good. So maybe you go in here and you make these one. I'm not going to do all of them now, but you can kind of see the idea that the edge face versus the exterior face or the void is a little bit different. And then for the inside, right, we have all of these. Object. So like that could be the outside, and then the inside faces could be a little bit different based on the surfaces that you have. Blah, blah, blah. There's definitely a line missing there. I don't want to do all this right now. So does that make sense? And then you can put on your hidden lines, but that's a little intense. You could also potentially deal with opacity. So maybe you put that at 75, just rather than having that mess kind of pop through. Cool. So you could deal with opacity, and you could try to do something cool like this, maybe. Still want them to show more. Right, so you can kind of find the visual aesthetic that you want to use for the project. So if you have any surfaces that are on the outside versus the inside. So you could have one where the hidden lines are kind of dashed in like this. Another version could be if you take the same view, right? You'll have the second version. The second version being, oh wait, other Rhino model. Turn off my hidden lines. Here's my other version. Right? Same thing. Right? This gets a little more annoying because they're not actually all that separated. So you could go in here and update the line weights. Maybe it's easier to select everything and then just update the exterior surfaces. Right? But you could also now take this that you're using for this version, and you could actually put it in your other model, Illustrator thingy, as a new layer. Just got to get the scale right because I didn't get the scale right. You actually use your other model. Oh boy. Might just have to go in and like delete some of the other faces. You guys see kind of what I'm doing and why I'm doing it? See? So instead of having all those lines being like all dashed and hidden line and weird, you can go in and kind of be more selective about what you want to show for the surfaces. Like maybe you don't need to show all the edges, right? Right. I found the painting. You could also, when you make 2D, right? If you look at the object, you can turn on scene silhouette. It'll create a separate layer for the outside edges of the project. So you can just trace that instead. So instead of turning on all the hidden lines, right? When you export it with the silhouette on, it'll give you the outside silhouette. So you could also use that to quickly update any accent to make the outside bolder. Or what I could do, which is great, is I could copy this and throw the silhouette into my area here. I have to scale it because the scale is a little different. It's probably not even the right angle. But basically, if I used the silhouette instead, it might look a little cleaner rather than all the hidden lines behind it, because it's going to be a lot of work cleaning all that stuff up. So instead, I could have something like this. Right. Still just always takes up like more cleaning up time, but at least I could use the silhouette. Instead of having all that stuff, I could have this instead of that, or I can use this layer and blah, 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 blah. All right. Does that make sense? And then I would put in the axon annotation layers. So we should start doing this now. I feel like this is the most convoluted lesson I've ever had in my life, but it's the most simple thing. I'm just making a union and I'm doing plans and sections, and then I'm making a difference and I'm making plans and sections. That makes sense?